Hello everyone, this is Neha Singh, your science teacher. In the previous video of acid, bases and salt, we have discussed about the physical properties of acids and the physical properties of bases. Now, in this in this video, we are going to explain about the chemical properties of acids as well as the chemical properties of the bases, means how they chemically react with other things on with each other. So let's start with the second part of our video, that is the chemical properties of acids and bases. The first point is here how they react with the metals. How do acids and bases react with the metals? Before going through that, we should know what metals are. As in our previous classes, we have already studied that metal is something which is are shiny appearance, which we call them, they are lustrous, they could be ductile, they are malleable, have sonority, and they're good conductors of electricity and the heat. So there are lots of properties of metals that we have already gone through in our previous classes. Now what we have to do, we have to learn about how do acids and bases react with these metals. Here the reaction is, whenever acid reacts with the metals, they form salt and the hydrogen gas is released from the equation, evolved during a equation, right? So here we have what we have taken an example of zinc, which is reacting with the H2SO4 here, which is all we have already discussed that it is a strong acid and it is forming ZnSO4 and H2 gas is evolving here, right? So most of the metals, they react with all the acids, or the most of the acids, they react with the metals to form the salt as well as to evolve, and they evolve the hydrogen gas. So from this reaction we can also say that the hydrogen is common to all the acids. There must be some hydrogen present in it so that they can give the hydrogen gas released out from it, right? That's why this is the main property of the acid as well. They have the hydrogen ion concentration in them, they have the hydrogen ion. So this property can be discussed here and this can be listed from this reaction also. But whether the hydrogen gas is evolving or not, how do we come to know? We come to know by a simple experiment. In this experiment, what we have done, we have taken the zinc granules, that is the zinc metal granules, in which we have added the dilute sulfuric acid, the reaction that we have already studied just here in the test tube. And after that, what we have done, we have seal the test tube and make a delivery tube into a soap solution. In this soap solution, when the gas will come out through this delivery tube, the soap solution will be filled with the hydrogen gas if it will be present. So to check the hydrogen gas, what we will do, we will bring the burning candle near this hydrogen gas evaporation bubble, right? And if as we know that hydrogen is a supporter of the combustion as well, so what it will, the hydrogen gas will give you a pop sound. The hydrogen gas will give you the pop sound when it will come in the contact with the burning candle. We can bring here the burning candle as well as the burning matchsticks, right? So the pop sound indicates that there is a evolution of the hydrogen gas when a metal reacts with any acid, right? And from this we can conclude that yes, the hydrogen is common to all acids. Clear? Now let's move further. What about the reaction with the bases then, right? Bases, all the bases, or we can say that the only few metals, they react with the bases to form the hydrogen gas. For example, what sodium hydroxide solution is heated with zinc. Here the sodium hydroxide is a base, right? And is again heating it, we are heating it with the zinc. So what we are getting? We are getting Ne2ZnO2, that is a salt, sodium zincate, and here the hydrogen gas is evolving, right? Here the main thing is the main thing that is need to be important, right? Here zincate ion ZnO2, it is actually the negative part that is forming through this reaction, right? So because the all the bases do not have the hydrogen present in them, only few of them, so because of that they form the negative ion with the sodium ion when we are heating them, and only few of them are releasing the hydrogen gas, and zinc is one of the example. So we can say that all metals do not react with the bases to form the hydrogen gas and pass this pop sound test, right? Now let's move further with the second property of the acids and bases, about how do they react with the metal carbonates and the metal hydrogen carbonates, right? Metal carbonate is metal, already know what it is, carbonate CO3, it is the formula carbonates, right? If we are talking about the metal carbonate, so if we are talking about sodium carbonate, that the formula will become Na2CO3, because the carbonate ion is having the two negative signs over it, right? And hydrogen carbonate HCO3 negative. So when we talk about the NaHCO3, that is the sodium hydrogen carbonate, which we also call it sodium bicarbonate. Now let's see the reaction. The reaction is when a metal carbonate or a metal hydrogen carbonate, they are reacting with the acids, what they are forming? They are forming salt plus carbon dioxide gas and plus the water. Let's see through an example. For example, dilute hydrochloric acid reacting with the sodium carbonate here, and it is forming NaCl, that is a common salt, CO2 and H2O. Again, if this is reacting with the, again this hydrochloric acid is reacting with the metal hydrogen carbonate, then it is again forming the NaCl, the salt, carbon dioxide and the water, right? Now in the previous chemical reaction we have checked for the hydrogen gas. Now we have to check for the carbon dioxide gas as well, right? So we already, how do we check this? We already know that when a carbon dioxide gas is passed through a slaked lime, that is the calcium hydroxide solution, CaOH whole twice, right? When we are passing it, then the calcium hydroxide solution will become milky in appearance, right? So this is the setup, whole setup what we have taken here, right? You can see in this we have taken the test tube in which sodium carbonate is there. We have added the dilute hydrochloric acid, again seal the test tube and pass it through the delivery tube into another test tube which is having the slaked lime, or we can say the lime water or the calcium hydroxide solution. So it turns to milky in appearance. But when the excess of hydrogen, when the excess of carbon dioxide, not hydrogen, when the excess of carbon dioxide is passed through it, what will happen? It will form a soluble salt of calcium hydrogen carbonate in the test tube, and the solution will become clear again. If it will become, this is the short test, we can say this will be the short test for the presence of the, or for the testing for the carbon dioxide gas. One more test for the carbon dioxide is there. What it is? What we do? If we bring the burning candle near the carbon dioxide gas, then it will extinguishing the fire. Why? Because carbon dioxide being being not a supporter for the combustion, right? We have already studied about this, that it is not a supporter of combustion, because of which we are using the carbon dioxide as in our fire extinguisher as well. Clear? Now the sodium hydrogen carbonate is also known as the baking soda, and it works as an antacid. Antacid are the things that are against. Ant means against, right? If we are talking about acid, so these are against the acid, so they work as an antacid to neutralize the acidity effect. Plus the marble, chalk, limestone, eggshells, they all are the same thing of calcium carbonate, CaCO3, and this CaCO3 is a form of marble, right? And if we are talking about in any question related to that, that eggshell is reacting with this particular atom or the particular acid, so what it will form, so that means you should remember that eggshells, here we are talking about the calcium carbonate, that is, it gives the reaction only with the acids. Now we have already talked about the acid, that all metals, carbonates and the hydrogen carbonates, they give the corresponding salts when they react with the acid plus carbon dioxide and water. And what about the bases? Bases, they do not give any reaction with them. They show no reaction when they are allowed to react with the metal carbonates and metal hydrogen carbonate. This is the main sure method, we can say that key main difference during the chemical properties of the acids and bases. Next, the third one, chemical properties of acid and bases, is the neutralization reaction, that how they react with each other, right? The acid is reacting with the bases, or how the bases is reacting with the acids. So when they react with each other, they'll form the corresponding salt plus the water. And this reaction, because they can neutralize each other effects, this reaction is called the neutralization reaction. The kind of salts formed during the acid and bases reaction, like when they react with each other, we will discuss it later on in this chapter only. So this is the third reaction, that it reacts with the bases and bases reacts with the acids to form the corresponding salt plus the water. The example is already given with the, which is sodium hydroxide, base, HCl is an acid, NaCl the salt, and H2 is the water. Next, and you can say the last comparison between the acid and bases chemical properties, that is the reaction of metallic oxide. One thing here to be noted, that metallic oxide is basic in nature. They have the characteristic as the bases is having. So because of this property, we can say that only metal oxides, they will going to be react only with the acids. Metal oxide being basic in nature and acid is acid, right? So what kind of reaction will be happening? The kind of neutralization reaction, the reaction between the acid or the bases. Here we have taken an example, metallic oxide, and when metal is reacting with the oxygen, so they will form the metallic oxide. Here example, CuO, that is a metallic oxide, HCl acid, the corresponding salt will be CuCl2 and the water, right? Similarly, when the non-metallic oxide, obviously the metallic oxides being basic in nature, so they cannot react with the base, so they are not giving any reaction with the bases. Now the non-metallic oxide, they are acidic in nature. Being acidic in nature, they will react with the basic solutions or a base, and it is also a kind of neutralization reaction. Non-metallic oxide, non-metals like carbon, it will be reacting with the base, that is calcium hydroxide, that will be forming a salt, calcium carbonate plus the water, right? So this is all about the chemical reaction of the acid, bases and salts. Here we can discuss the summary. The first, reaction of acids, they react with the metal carbonates and forming salt, carbon dioxide and water. Here bases do not react with the metal carbonates or the hydrogen carbonates to give the corresponding salt and the water and the carbon dioxide, right? Next, they are reacting with the metals and forming the salt plus the hydrogen gas. Bases also react, but only few metals can react with the bases to give the hydrogen gas plus the salt. Next, acids are can be reacted with the metallic oxide, but bases do not, right? And acid and bases, they react together and they are forming the salt plus the water. This is all about the chemical properties of the acid and bases. In our next video, we'll be discussing more about this chapter. Thank you everyone, and we'll be meeting in our next video. Till then, take care.